I feel like this is going to spill over into a part 4, but let me do something that we haven't done yet that I often test on. So it gives me a fraction and it wants me to find the derivative of that fraction. So how do I find derivatives? Well, I create 2 points. The first point in 12a, its x coordinate is going to be x. Its y coordinate is going to be 3 over x. That's easy. In fact, the second point, its x coordinate is x plus h. Its y coordinates happens when you change that x to x plus h. It's 3 over x plus h. Here's my 2 points. Fractions are not my friends. Part of the difficulty in calculus is the algebra is yuck. And this is going to be as ugly as it gets. So let me find the derivative. For number 12, the derivative is the limit as h goes to 0 of y2, which is 3 over x plus h, minus y1, which is 3 over x, all over h. I need to get common denominators in this numerator. What I'm going to do for this left fraction is very carefully multiply it by x over x. And for the right fraction, I'm going to multiply it by x plus h over x plus h. And what this is going to give me, I'll really show every step here because this is not so easy. The numerator of my fraction is going to be 3x over x times x plus h minus 3 times x plus h over x times x plus h. And instead of big divide, parentheses, divide with a divide sign. So this denominator, I need a 3-layer fraction is never my friend. I'm changing this big fraction into a divide by h. So my derivative is the limit as h goes to 0 of 3x, and then it's going to be minus 3 times x. So this minus, let me just write it here, minus 3 times x plus h over x times x plus h, and then instead of divided by h, multiplied by 1 over h. Dividing is the same as multiplying by the reciprocal. I'm changing this divide to a multiplication of the reciprocal. Now in the numerator, I'm going to get rid of that parentheses. I'm going to leave the 3x, and I'm now going to go minus 3 times x, which is minus 3x. Minus 3 times h is minus 3h over x times x plus h. I don't think I need this big parentheses anymore. Times 1 over h. In the numerator, those 3 x's cancel. And I'm left with f prime of x equals the limit as h goes to 0 of negative 3h over x times x plus h times 1 over h. This h and that h will cancel. And I get the derivative is the limit as h approaches 0 of negative 3 over x times x plus h. Now I can plug in 0 and get the derivative equals negative 3 over x times x plus 0. That's negative 3 over x times x. And my answer to part A, the derivative, is negative 3 over x squared. That's a lot. Together, step by step, hopefully it's followable. So the answer to 12a, the derivative, f prime of x, is negative 3 over x squared. Part B wants me to find f prime of 4. So for part B, f prime of 4 is just going to be negative 3 over 4 squared. It's just going to be negative 3 over 16. There's a few more of those in 13 and 14, but I'm not going to do two of them. You can look at my solutions and let's Zoom together or ask me in class how to do 14 or 13 if you can't get them, just to make the videos not as long as they can be. Problems 15 and 16 want me to find an equation that can be used to find the slope of the tangent line. That's the derivative, and then it wants me to find the actual slope of a tangent line. So let's go ahead and do that. So part A, the formula to find the slope of a tangent line is just the derivative. To find the derivative in part A, I need to create 2 points. So as I go to do part A, my first point, its x coordinate's going to be x, its y coordinate's going to be x squared minus 2x plus 3. My second point, its x coordinate's going to be x plus h, and I need to do the side work to get the y. The y coordinate's going to be x plus h quantity squared minus 2 times x plus h plus 3. This part here is x squared plus 2xh plus h squared. That's what that would come out to. This is going to be minus 2x and then minus 2h, and I still have the plus 3. So those are my 2 points. Now I'm going to find the slope of the line that connects those 2 points to get my derivative. So for 16a, I'm going to say the derivative f prime of x is the limit as h approaches 0 of this long string here, x squared plus 2xh plus h squared minus 2x minus 2h plus 3 minus this y. Technically it's going to be minus x squared minus 2x plus 3. I'm going to write minus x squared plus 2x and minus 3 to save some ink all over h. And now cancel. The x squareds cancel, the 2x's cancel, and the 3's cancel. The only thing left in the numerator are the 3 terms with an h. I factor out the common factor of h and get f prime of x is the limit as h goes to 0. The denominator is h. In the numerator, I factor out an h. From the 2xh, I'm left with 2x. From the h squared, I'm left with plus h. From the minus 2h, I'm left with minus 2. I cancel out the x's, and I get the derivative is the limit as h goes to 0 of 2x plus h minus 2. That's going to be 2x plus 0 minus 2. The answer to 16a, the derivative, is 2x minus 2. That's the grunge. Now I need to actually find the equation of the tangent line, which is grungy but not so grungy. So the answer to part A, f prime of x equals the 2x minus 2. Let me find the equation of a tangent line. To find an equation of a tangent line, I need a point and I need a slope. The only thing I know is the x-coordinate of the point is 4. To get the y-coordinate of the point, I use the original function. So my y is going to be 4 squared minus 2 times 4 plus 3, which is going to be 4 squared minus 2 times 4 plus 3. The y-coordinate of my point is going to be 11. I feel like I did this problem already. Yeah, it is what it is. And now my slope, I'm going to plug 4 in for here. I'm going to get f prime of 4 equals 2 times 4 minus 2. That's going to be 8 minus 2. That seems like a new number to me. That is 6. So plugging numbers into the derivative gives me slopes. Plugging x's into the original functions gives me y's. So I have a slope and a point. To find the equation of my line, I'm going to go y minus the y-coordinate of the point, which is y minus 11. equals the slope, which is 6, times x minus the x-coordinate of the point, which is 4, fading. This is going to give me y minus 11 equals 6 times x and 6 times minus 4. So y minus 11 equals 6x minus 24. Add 11, and get y equals 6x minus 13. That's my answer to part B. I want to do another find an equation of a tangent line, but I don't want to find another derivative by hand just because we've done a lot of them, and that's a big time waster. We're told, I said to skip 17 and 18. I think I have a little too many problems here. And I'm going to do 19 with you. Actually, I'm just going to do 19b with you. I know how to do derivatives in my head. I'm going to give you the answer to 19a, which you should be able to do using limits. The answer to 19a, the derivative of this, is going to be 6x minus 2. So for 19a, I'm going to skip it, and I'm going to move on to finding the equation of the tangent line. To find an equation of a tangent line, I need a point, and the x-coordinate of the point is supposed to be 1. The y-coordinate of point I need to find out, and I need a slope. The slope I get by taking the value of x that's provided, which is 1, and I plug it in to the derivative. And when I plug 1 into the derivative, I get 4. So for problem 19, the slope is 4. To get the y for number 19, I'm going to plug in 1 for each of the x's. I'm going to go 3 times 1 squared minus 2 times 1 plus 3. That's going to be 3 minus 2 plus 3. If I haven't messed up, it's 4. Been shooting videos all day, so let me make sure. 3 times 1 squared minus 2 times 1 plus 3, you get 4. So I have a point, I have a slope. Let me find the equation of the tangent line. Doing y minus the y-coordinate of the point equals the slope times x minus the x-coordinate of the point. This is going to give me y minus 4 equals the 4x minus 4. This is a surprising answer. Add 4 to both sides, and I get y equal to 4x for the equation of the tangent line in 19b. Let's do another one together, all in fraction 1. Part A of number 21, I want to do first. I want to find the derivative, which is the formula to find the slope of a tangent line. So for 21 part A, I need to create 2 points. So I'm not going to do my 22. I'm going to do your 21 with you. My first point, the x-coordinate is going to be x. The y-coordinate's negative 8 over x. My second point, the x-coordinate's going to be x plus h. The y-coordinate's negative 8 over x plus h. Those are my 2 points. Easy to get the 2 points, hard to get the derivative. So the derivative, which is the equation to find the slope of the tangent line, is going to be the limit as h goes to 0. Subtract in the numerator y2 minus y1, and the denominator gets an h. This double negative I can make a plus, just to make sure that I don't mess that up. This is the limit as h goes to 0 of negative 8 over x plus h plus 8 over x. And then instead of the 3-layered fraction, change the 3-layered fraction into a divide, and then we're going to multiply by the reciprocal. Let me multiply this fraction by x on the right side in the numerator, left side in the denominator to make the fraction have a nice denominator. And the second fraction, I'm going to multiply numerator and denominator by x plus h. So this is going to give me the derivative is the limit as h approaches 0 of negative 8x over x times x plus h plus 8 times x plus h over x times x plus h. and then times the reciprocal of h, which is 1 over h. Let me work on this numerator now. I get the limit as h approaches 0 of negative 8x, and then plus 8 times x is plus 8x, and then plus 8 times h is plus 8h, over x times x plus h. When I make the two fractions into one, I don't really need the parentheses anymore. So this gives me the derivative, or the formula to find the slope of a tangent line, is the limit as h goes to 0. In the numerator, the 8x's cancel. I'm left with 8h over x times x plus h times 1 over h. I can now cancel the h's and get the derivative, or the formula to find the slope of the tangent line, is the limit as h goes to 0 of 8 over x times x plus h. Now I can plug in 0 for h and get 8 over x times x plus 0, which is 8 over x times x, which is 8 over x squared. For 21, the answer to part A, the derivative, is 8 over x squared. So I'm going to write that down, and I'm going to use that to find the slope of my tangent line, and I'm going to get the answer for the equation of the tangent line. So for part A of 21, the derivative is 8 over x squared. Part B wants me to find the equation of the tangent line when x is negative 3. Not fun, but I'll deal with it. When x is negative 3, the x-coordinate of the point is negative 3. To get the y-coordinate of the point, I'm going to go y equals, use the original function, which is negative 8 over x, leave the negative 8 in the numerator, plug the negative 3 that was given to me into the denominator for x, and the y-coordinate of the point is going to be 8/3. Next, I'm going to find the slope. I find the slope by plugging the x value into the derivative. It's going to be 8 over negative 3 squared. The slope is going to be 8 over 9. Fractions are not my friends, but I'm going to push through them. So now I have a point and a slope. I can find the equation of my line for 21b. 21b, I'm going to go y minus the y-coordinate of the point equals the slope times x minus the x-coordinate of the point. So y minus 8/3 equals 8/9 times x minus negative 3. I'm going to make that double negative positive, so y minus 8/3 equals 8/9 times x plus 3. This gives me y minus 8/3 equals 8/9 x, and then I'm going to do 8/9 times 3. That's going to actually be 8/3. I'll show you on my calculator that I could do this if I'm not comfortable with these fractions. To do 8/9 times 3, I put 8 divided by 9 in a parentheses, hit times 3. It gives me a decimal. If I hit math and then enter once, enter twice, I get 8/3. This 9 cancels with that 3. The 3 becomes a 1. The 9 becomes a 3. So the denominator, or this multiplication, comes out to 8/3. And I'm almost done. I just need to solve for y by adding 8/3 to both sides. So plus 8/3 and plus 8/3. And for 21b, the equation of my tangent line is going to be y equals to 8/9 x, and 8/3 plus 8/3 is 16/3. Thought there was too many problems, so I suggested skipping 23 and 24. I thought we would do maybe 25 together and maybe 30 together, and let's do 25 together. find the derivative manually. On 30, I'm just going to give us the derivative just to save some time because it's the long part of the computations. So this problem 25 gives me a toy rocket. It's launched in the air. Its height in meters after seconds is given by this formula. First, find the derivative. And what's the derivative going to measure? Well, for each one of the points in this, the x's represent the time in seconds, and the y's represent the height in meters. What the derivative is going to give us is the speed, or the velocity, in meters per second, because it's y per x. So when I go to do part B, I'm going to get the rocket's speed, and this speed will have a sign. If it's positive, it's getting higher. If it's negative, it's getting lower. So its speed is technically velocity when we're dealing with a position function like we have here. So let's work on the derivative. The first point, the x coordinate is going to be t. The y coordinate is going to be negative 2t squared plus 30t plus 5. Second point, the x coordinate is t plus h. The y coordinate is negative 2 times t plus h squared plus 30 times t plus h plus 5. This is going to be negative 2, and then this I have memorized. This is t squared plus 2th plus h squared plus 30 times t plus h plus 5. So the y coordinate is going to be negative 2t squared minus 4t minus 2h squared plus 30t plus 30h plus 5. So those are my 2 points. Now I'm going to find the derivative. For part A, the derivative, s prime of t, is the limit as h goes to 0 for my fraction, and this junk goes first, negative 2t squared minus 4t minus 2h squared plus 30t plus 30h plus 5. After it, I'm supposed to put a negative, and then in a parentheses, negative 2t squared plus 30t plus 5. If I clear that parentheses, I'll get positive 2t squared, negative 30t, and minus 5, and the denominator is just h. So now I'm going to cancel everything that doesn't have h's. The negative 2t squared and the positive 2t squared cancels. The positive 30t and the negative 30t cancels. The positive 5 and the negative 5 cancels. The 3 terms, this is supposed to be 2th. This is supposed to be 4th right there. I just didn't write the h down for some reason. This right here, when I did this, it should be minus 4th. I forgot this h. And I knew any term that has a t should cancel and everything else should have h's, so I noticed I forgot that h. I'm going to factor out an h in the numerator. I'm going to get s prime of t is the limit as h approaches 0 of h times, from the minus 4th, I'm left with minus 4t. From the minus 2h squared, I'm left with minus 2h. From the plus 30h, I'm left with plus 30 all over h. Cancel out the h's, and I get the derivative is the limit as h goes to 0 of negative 4t minus 2h plus 30. I'm going to change that h to 30 and get s prime of t, or the derivative, is negative 4t minus 2 times 0 plus 30. So the derivative is minus 4t plus 30. That's the answer to part A. So for 25, the derivative in part A is just negative 4t plus 30. For part B, it wants me to plug 2 into the derivative, and it's going to give me the velocity in meters per second. When we have a position function, a function that gives you the height versus time, the derivative gives you its speed in the y units per the x units. So for part B of 25, s prime of 2 is going to be -4 times 2 plus 30, and I think that comes out to 22 positive. And so the rocket, its velocity or its speed is 22 is the number, and its units are meters per second. I want to do one marginal profit problem, but I'm going to give us the derivative to save some time. The derivative would be grungy to find, but we did one earlier. We could do it again if we had to. I picked cell phones because they seem current. I just rewrote this material for brief calculus, and in some of the problems I used the word smartphone because when I wrote this, not everybody had, what we would call a phone now. Some of us still had flip phones or Blackberries, if you even know what that is. So let me give you the derivative in 30A, and I want to just work the derivative. So 30 gives me a profit function for selling X cell phones. This function, if I put a number in for X, it gives me the total profit for selling that many cell phones. The marginal profit function is the derivative of the profit function, and I'm going to just do that because I know how to do this quickly in my head. It's 450 minus 0. I'm not going to make a mistake on this last problem. 0.55 times 2. 0.045 times 2. It's minus 0.11x. That's what the derivative would be if I did the full-on work that I should do rather than using the shortcut that I know from chapter 2. What I really wanted to focus on is this, plugging 1,000 into the marginal profit function and interpreting. So I should do this manually by creating 2 points like I've done for all my derivatives, but let me do this part. It's the part I want to spend the last little bit of time on. So I'm going to plug 1,000 into the marginal profit function, and that will tell me how much extra profit I'll get by selling the 1,001st smartphone. Haha, cell phone. No longer smartphones. Well, they're all smartphones, but it's not like a special name anymore. So this gives me the marginal profit function evaluated at 1,000 cell phones gives me $340. And what does that mean? That means we're going to make we're going to make $340 of profit. So $340 of profit will be made by selling the 1,001st cell phone. Marginal profit tells me the additional profit by selling the next item. So the next item from the 1,000th cell phone is the 1,001st cell phone. And the extra profit, the company is going to make more than $340 by selling 1,001 cell phones. It just makes an extra $340 by selling the 1,001st, one more than the number in the parentheses. So that's the end of the new material for the chapter. What we're going to have next are a couple of practice tests. There's going to be one practice test in an online class on my webpage and one on Canvas. In an in-person class, maybe we won't have the Canvas one, but I could always put it up. So now we need to focus on the practice tests. Any question that's going to be on the test from this chapter is going to be absolutely identical with maybe just numbers changed to something on the practice test. So now that we've done all the new material, we just need to start beating on that practice test. When you're studying for the test, that's 100% what you should be studying for. Just repeat the practice test over and over until you can kind of do it without looking at it, and you'll be great for the test.